Good
All
morning,
right.
good afternoon, everyone. Thank you for joining us for today's office hours for November 2023. This should be a really good topic today. We look forward to covering it with you. Before we start, just a couple of housekeeping items. Please do leave yourself on mute until the end of our session, at which point we'll open it up to a general Q&A. This session is being recorded. It will be available up on our community site, as always, sometime late this afternoon or early this morning. And with that, I'm going to turn it over to Ben.
Thanks, Bill. And hello, folks. Ben Urbanski. I'm the Layer7 API Gateway Product Manager. And today we're going to talk about API Runtime Security. So very specifically, what we do to secure APIs with our Layer7 API Gateway at runtime. And really to help position where we fit in the kind of rapidly expanding API security market sector that is solving a lot of different problems related to security, but not so much at runtime like we do. So with that, let's get started. Quick disclaimer, I'm not going to emphasize it. We usually show this in front of our roadmaps in case we're discussing any future functionality, though we have a good track record of quickly delivering many features on time. We can never guarantee that we'll deliver them on time or at all. There's not going to be so much of that in this presentation, but I might mention a few progressive delivery features that frankly are already available as experimental or preview, and of course then are on our roadmap to take to GA over time. This is going to be our agenda. We'll quickly talk about high-level Layer7 API management use cases with an emphasis on security. The rest of this presentation is going to be all about security and securing your APIs at runtime. We'll take a quick look at what security means, the different API security considerations that customers have, and the Layer7 API Gateway features that help address those considerations. We'll provide some recommendations on how to get started with securing your APIs using Layer7, and a quick demonstration showing how we put those recommendations into effect. So Layer7 has several products that support a very complete API management solution. At the center of those is our API Gateway. And back when Layer7 was founded, that's the only product we had. And that product was focused on being a security gateway for your services and APIs. So that's how we differentiated ourselves then. That's how we've long differentiated ourselves in the market. Most of our customers bought Layer7 to secure their APIs, and that's the reason that most customers continue to use us today. So despite the fact that we support many different use cases, from security to integration to traffic management to full lifecycle API management, security is, the number one use case our customers have had for us over time. And that's whether they're deploying us to their DMZ to secure external traffic to their internal services, or outbound requests from inside to external services, or whether they're deploying us to their internal zones to secure internal only API traffic, which frankly is perhaps not just as important, might be more important. Most people think about security when they start to consume or provide things externally, but the industry's long said that upwards to 80% of successful exploits happen inside a customer's own four walls, right? So internal security, again, as important, if not more important. And really, at the end of the day, that just comes down to where you deploy your gateways to sit in front of which services, but otherwise they're largely providing the same or at least similar security capabilities on behalf of those services. So what do we mean when we say security? I like to look at security as an exercise in risk analysis, which you could break down in two ways. You need to first assess your risk, and then you got to manage the risk that you've assessed. So what do we mean by assessing risk? This is identifying what your risk is. Once you know what your risk is, then you can decide what you're going to do about it. So when you're assessing your risk, it begins with identifying your assets, right? What are your applications, your APIs, your data, right? Those are all your assets. And then you want to consider threats to those assets. And finally, how are those assets vulnerable to those threats? And it's really only where the three of those things meet that you have risk, right? If you don't have assets, you don't have risk. If you have assets, but there are no threats to them, you don't have risk. If you have assets and there are threats, but you're invulnerable to all those threats, you don't have risk, right? You have risk when you have threatened assets that are vulnerable. So what do you do about your risk? Well, largely the industry recognizes 4 different things you can do with risk, beginning with avoiding it. And we've seen plenty of that over time. Way back when SOAP services were just becoming a thing. And then it was later true of RESTful APIs, which were sort of the new kid on the block, right? We worked with plenty of organizations whose security departments were not going to let the developers publish those things externally because they didn't know how to secure them, right? So they were avoiding the risk by saying, no, you can't have services or APIs, or you can't expose them externally. But we know that's not a good option for most people most of the time. There's real valid business reasons why people want to have services and APIs and even expose them externally. Then there's reduction. And that's doing things to reduce the risk you have. Frankly, that's where we come into play, right? Our API Runtime Security allows you to reduce your risks. After that, you have sharing of the risk. That's where you insure yourself. So if you haven't reduced your risks entirely or at all, and then that risk is realized, you have some insurance to protect yourself from the consequences, right? And then finally, there's retention. That means you've got the risk, you're doing nothing to reduce it, you're not insuring it, you're just accepting it, you're vulnerable to it, you're hoping it doesn't happen, right? So again, when we talk about API runtime security with the Layer7 API gateway, we're talking about doing things to actively reduce your risk so that you don't have to avoid, creating services and APIs and making those available externally or even internally. So what are all the things people should be considering when it comes to securing their APIs at runtime? This is I'd like to think, concise yet fairly complete list of all of the security considerations we've identified and supported with different gateway capabilities over time. I'll go through all of these in more detail, and then we'll make recommendations related to these, and I'll demonstrate using the gateway to support many of these things near the end. The first one is, the idea that you do want to select a security solution like our Layer7 API gateway, but one that differentiates itself when it comes to security in the marketplace by being one of the very few security gateways that has common criteria certification, and the only one that has it at the level we do. And, as recently as we have, done it, we are in the process of wrapping up our latest common criteria evaluation on 10.1 CR2. And then we are going to begin the next common criteria evaluation on 11.1 or 11.1 CR1 right away to continue to stay up to date on that. We harden our appliances based on STIG profiles. We're FIPS 140-2 compliant in all of our form factors, and we can support FIPS 140-2 level 3 with integrations with HSMs. We tune ourselves to optimize performance at scale in our special purpose gateways. And all of that is important because, nothing is free. And people want to do many things when it comes to securing their APIs. And all of those things are going to have a runtime consequence, right? So the ability to do all of those things, quickly, and at scale is very important to make it possible to do those things at all for our customers. We also support, industry standards, and often, new and emerging industry standards. So why is that important? It's important because, you don't want to roll your own security. You want to adopt industry standards that provide the security you want and need. And then supporting those standards make you more compatible with the services you put us in front of, the consumers that are calling those services through us. And those standards themselves are very complex and evolving. So it's difficult for individual customers to pick up, even one, much less many, new and evolving standards and fully understand them and otherwise implement themselves. We do that hard work for you, and we make it easy to configure us to support those standards, and then we keep up to date with them. That's huge. Service virtualization, that's a, more of an integration concept, but it has security implications. By being able to virtualize your services in several different ways, identity via routing, protocol via bridging, interface via transformation, we're able to hide implementation details from attackers. Identification, authentication, authorization, you could tag auditing on the end of this, often referred together as AAA. All of these things are important for controlling access to your services or APIs through the gateway. We support many different ways of doing those things based on industry standards, but also even proprietary mechanisms that are commonly used by our customers in the industry. We not only support many different ways of identifying requesters, but we're also to do that, we're also able to support federated identification based on different industry standards. We're also able to broker between different types of identities. And here below that, the third bullet down, you can see a to LDAP directories or other identity services that we support. Confidentiality. That's all about protecting the confidentiality of your data in motion and at rest, and usually means using encryption, either by using a secure transport like TLS or some encryption standard to encrypt your messages at rest. Integrity. That's about making sure that the message content that's being received hasn't been changed since it's been sent, right? It's maintained its integrity from the consumer all the way back to the service, and that's largely accomplished by signing and verifying digital signatures, and again based on industry standards. Auditing and logging, very important for tracking activity, beginning with even just auditing the configuration changes of your gateway, but also auditing the message going through your gateway, auditing and logging when error or other events occur while processing those messages. We provide good and very configurable out-of-the-box ways of doing all that. We've got a lot going on in this category around upcoming support for open telemetry to off-box that in new and better industry standard ways that will be easier to plug into your existing environments, as long as they also support open telemetry. Non-repudiation, that's all about being able to kind of prove in a court of law that you did receive the request and it was sent by a certain individual and it hadn't changed in between. And you kind of accomplish non-repudiation with a combination of auditing, logging, and digital signatures, all of which we provide many capabilities for. Data classification and compliance, that's about making sure that your XML or JSON messages are well formed, that they're valid according to the schemas that describe them for the services and APIs. Threat protection. And actually, last but not least in that category, also just the concept of being able to inspect the contents of your requests and their metadata, and validating them, masking them, filtering them, encoding, inputs, decoding outputs, all fall into that category. Threat protection, is also something that people often first think about. It's something that we do in many different ways to protect against many different threats. You get a lot of threat protection just by deploying us in line with your gateways, even if it's just as a services, even if it's just as a pass-through proxy. But there's many additional things you can do on top of that using policy assertions and the policies of your services on the gateway. And many of those are listed here. All the way up through virus scanning of message contents or attachments by integrating with, off-gateway virus servers using the ICAP protocol. So those are many API security considerations that customers do have or should have, and then the many capabilities of our gateway to address those considerations. We'll still occasionally run into people that are, falling back on just doing everything over SSL and thinking that protects them, right? When we run into those people, we ask them these questions, right? There's many more things that you should be doing to protect your APIs above and beyond just making sure you're using a secure transport. Now, that's a lot, right? There's a lot to consider, from what assets you have to what's threatening those to how they might be vulnerable, to identify your risk, and you have to make a decision on what you're going to do about it. And there's many things to consider when you're making that decision, and there's many capabilities that you might need to bring to bear to address those considerations. It can be overwhelming, right? So where do we recommend you start if you're going to deploy our gateway in front of a service or API to get maybe maximum security for least amount of effort, if you will, and address many of those things we've already talked about? First, you want to reduce your traffic and only expose what's needed, and require that all traffic goes through the gateway. So you want to put a gateway in front of your services or APIs. That's only the first step, though. If you still allow people to go around the gateway, then you're allowing them to bypass all the additional security that the gateway is going to enforce for you. So you have to consider your last mile security. How do you secure that last mile between the gateway and your service or API and control that all the traffic goes through the gateway to get to your service and API? And there's a variety of ways of doing that, from just your network topology to make sure that your services and APIs hosted on the servers that they are only accessible through the gateway from a networking perspective. But also you can implement ACLs on your servers to only allow traffic to them coming from the gateway. You can implement mutual TLS between the gateway and those services on the servers so that, the gateway has to present a valid client certificate with this TLS connection to the service on that server. And then there's other more high order things that you can do, but it's very important to first deploy a gateway in front of your services and then control that all traffic's going through your gateway. And these are some of the ways you can do that. Then you want to use discrete error messages, right? You want to make sure that your error messages are useful, but you don't want them to be revealing. You don't want your error messages, you want your error messages to be useful to your developers and your administrators for, troubleshooting when errors are occurring as they call services through your gateway. But you don't want the information to be useful for attackers to understand how you're securing those services and to be able to get around the security. Then you do want to use a secure transport, right? But you don't want to stop there. The secure transport's, more or less a standard, and it provides that end-to-end encryption for confidentiality of your, traffic, in motion. But there's many more things that you should be doing on top of that, including controlling access. So, having some form of access control that identifies the requester, only serves requests to, authenticated identities, possibly includes additional authorization. And there's lots of ways you can do that. And you can do that in many different ways in the same policy of a single service. And you can do that using identity federation, and you can even broker that identity from the front side of your gateway to the back side of your gateway. But you should do some level of access control using identification, authentication, optionally authorization. Then you want to enforce a strict interface as long as your service or API allows for it, because it's either XML, SOAP, or JSON based, and it has some supporting schema that you can validate against to validate the protocol being used, the resource being requested, the method being used to request that resources, and additional parameters in the metadata or message itself, again, based on a well-defined schema. Additionally, you might want to validate and optionally encode, input, and optionally output parameter values. In some cases, your schema will do some of that for you, again, depending on the schema and how thorough it is. In other cases, you can do additional input-output validation in policy. And then rate limiting is really a must-have. It's one of the features that every solution like this has. It's probably one of the most commonly considered and used features of solutions like these. You want to have some rate limiting in place to not exceed the capacity anywhere. So what do I mean by that? Not to exceed the capacity of your gateway, not to exceed the capacity of your services hosted behind the gateway, is the basic expectation of rate limiting. There's also throughput quota enforcement to enforce contractual SLAs you might have, or for accountability. That's kind of considered extra. Rate limiting is sort of the lowest bar, just to protect you from overwhelming your resources anywhere in an end-to-end transaction. And then monitoring. Monitoring all of this at runtime so that you can detect when any of these security measures are being violated, if you will. You want to be alerted to that. You can be monitored by our gateway via on-box or off-box audit and logs. So a lot of capabilities there as well. So this is sort of our recommendation for getting started with API security using our gateway, pretty much in front of any API. Now, again, you're going to have unique requirements that come out of your own risk analysis that may lead to exactly this same list of things you should do. You may have to do fewer of these things. You might have to do more things. As you saw from previous slides, our gateway is capable of doing many more things than this, right? But again, like I said earlier, nothing comes for free. So you want to be efficient in what you do to meet the requirements you have, so you can do it more quickly and easily and at scale with a lower cost. So with that, let's go and do a demonstration of using our gateway to implement many of those getting started recommendations, if you will. So in my environment, I have a gateway that I'm going to use to protect a publicly available pet store API. I'm going to call that API through my gateway using Postman as a client. I have an LDAP directory in my environment that I'm going to integrate with to do LDAP, authentication of basic auth credentials. At one point, we'll show other ways of controlling access using mutual TLS and OAuth. And I'll be I'll be publishing the policy and making a lot of the policy changes using our Layer7 policy manager. So with that, let's go to the demo. And again, maybe I'll step back a slide. We're going to be walking through this list of recommended things to do to get started with securing your APIs, during the demo. So this is sort of our path, if you will, for doing that. The first thing I'm going to do is I'm just going to call that pet store API directly. So this is not going through my gateway. This is going to the pet store API on the internet. I'm going to send this request to place an order, and I get back a response. Now, again, the first recommendation is to reduce your attack surface and require that everything goes through the gateway. So I can do that based on my network topology, not allowing requests to pet store unless they go through my gateway. Also making sure that requests can't go around my gateway if the network would otherwise allow that, by doing something, for my last mile to make sure that my API only serves requests that have first come through the gateway. However, if I send a request to my gateway right now, I'm going to get back an error because I haven't published my service to the gateway. So let's do that. This is Policy Manager connected to my gateway. I'm going to go ahead and publish this API. We'll call it Pet Store. This is the target URL. Notice it's using HTTPS to connect to the Pet Store server, passing through the request path and query that is received on the front side of the gateway. At this gateway URI, I'll click Finish. Now, again, one way to make sure that a backend service only accepts requests that come through the gateway is to use mutual auth TLS, which means you configure the service or server serving it on the backside to require that the gateway sends a client certificate with its TLS connection. Now, the gateway will do that automatically using its default SSL key, but you can also specify more specific keys, and there can be many keys, and you can specify them per service or server. You can do it with static configuration like you see here. You can do it with dynamic configuration by specifying the required key using a context variable at runtime. Now that I've published my service on the gateway, I can go back to Postman, make that same request again, and now we get back a response through the gateway. So you saw that previous error was a SOAP fault. That goes way back to the very beginning of the Layer7 API gateway when everything was all about SOAP. That's pretty baked into the gateway, but I'll actually be showing you here soon a way to easily override that at a global level, or in policy. So that kind of takes us back to discrete error messages. I'll show you some ways you can control the way the gateway returns error messages globally or in policy and throughout your policy, so you can tailor them to your needs. And then I'm going to open it back wide open so that we get very verbose error messages to demonstrate some of the other concepts that we will throughout the rest of the demonstration. We're also going to look at the gateway requiring a secure transport right now. You notice I was able to send this request through my gateway using just HTTP. If I go back to the policy of my gateway now, I can require that the client uses TLS. I'll save this change. I'll go back to my client, send the message again. Notice we still get the SOAP fault. Let's go ahead and change the way we see error messages returned from the gateway. One way to do that is with using assertions in your policy. There's several assertions that can control the way error messages are returned from your policy. One of them, though it's being less used today, is this customized SOAP fault response as a generic assertion. I show it to you because it's still useful in RESTful APIs and gives you several options. And a fun one that I've used on occasion is just to have it drop connections if there's any policy error. I was asked by a customer at one point to help them create a policy that would pass a penetration test being done by a third party. And this is one of the techniques we used. And believe me, that third party didn't get very far. You know, the service worked as expected when it received valid requests. And in any other case, it just dropped the connection and just left the pen tester scratching their heads. So what would that look like if I tried to send a non-SSL request? A disconnect right here. Now, that's still not a very useful error message, right? And even in this one assertion, you can configure it to provide increasingly useful messages, but especially for RESTful APIs that are mostly JSON today, you don't want to be returning SOAP faults. So another way of doing that at the policy level is just to use this customized error response assertion. By default, it's going to return a 500 error with an internal server error body. We'll do that here just for the sake of example. Try to send that same non-SSL request. Now we get back a 500 response saying internal server error. The nice thing about this assertion, it's very flexible, and it basically sets the error message that will be used for any policy error that comes after it. And so you can embed different versions of it throughout your policy to, provide more specific errors if the following policy assertions fail. Let me show you what we can do at a global level. I'm going to go ahead and disable this error handling in policy. And I'm going to go to some cluster-wide properties that let me control the default SOAP fault behavior, beginning with this cluster-wide property that has 4 options, one of which is to return a template error, which then in turn is governed by this error template that is configurable and can use context variables to provide useful but not revealing information in a non-SOAP format. In this case, this is JSON, right? So now let me go ahead and send another request that will receive an error. And this is the message I get back. And so not SOAP, but JSON. Useful because I'm being told here in a way that's not revealing to attackers, but it's going to be very useful to administrators, which node this error occurred on, which request this error occurred for on that node, which, as you'll see as we get to the end of this demonstration, is very useful when you're looking at audit records or logs to try to troubleshoot a problem that might be reported to you by a consumer of your service. Now, like I said, I'm going to open this back up to return a very verbose, and in this case, SOAP fault message, just to make it easier to see why our policy is failing as I continue to add assertions to this policy to address all those security recommendations we made on that last slide in the presentation. So to do that, I'm just going to set the SOAP fault level up to 4, which is its maximum level to provide full detail, basically a stack trace of your policy assertions all the way down to the one that failed, giving us real instant feedback on what's failing in policy as we go through the rest of this demonstration. So next, we're going to discuss controlling access, right? And one real quick way we can do that is just by requiring mutual TLS on the front side. And that's as easy as going to our require SSL or TLS transport assertion and requiring a client certificate for authentication. This assertion just challenges for a certificate and fails if one's not presented, but it doesn't actually authenticate that certificate that's presented is a trusted certificate by the gateway. So we also have to authenticate the certificate against a federated identity provider, which can, against an identity provider of whatever type that can be used to validate client certificates directly or through a trust chain or tied to a user's identity. And in this case, I'm going to authenticate the client certificate sent via mutual TLS against this trusted client certificates federated identity provider that I created on the gateway. If I search that identity provider, you're going to see there's only one assertion in it. One certificate in it at this time with a subject DN of client 1. And I'll be using client 1 and client 2 certificates to demonstrate this capability. So now if I go back to Postman and send this HTTP request, I still get a failure because no client certificate was presented. If I go into Postman and tell it to send client certificates, but not a trusted client certificate, I'll get a different error. Now, Postman does this keyed to a specific host using some key cert file for the MTLS connection. I'm going to select my client 2 certificate. So now Postman has a certificate to present, but I still get an error because it's not a certificate trusted by the gateway. So let's go ahead and specify a trusted certificate, which would be that client 1 certificate. For which I'll select my client 1 P12 file. Send the request, and I get back a valid response. So that's controlling access based on something the consumer has. Again, we can control access in many different ways and in multiple ways at the same time on the gateway, requiring something the consumer has, something they know. We even have integrations with other solutions that can, authenticate multiple factors, including, something about who they are, right? The next thing I'll show is how we can do user identification by using basic auth authenticated against LDAP, which is kind of antiquated, but frankly is still commonly seen in the industry, right? There's still a lot of basic auth with LDAP authentication out there. And we do that very easily and well. First, by requiring the basic auth credentials, and then authenticating them against, in this case, an LDAP identity provider. And I'm using Apache Directory Service that I set up an LDAP identity provider for. If I search that for users, you'll see a number of users and groups in there. So now, having made that change, if I go back to Postman and I send a request with a valid client certificate but without basic auth credentials, I get your standard 401 authentication required response from the gateway. If I go to a similar request that has that's sending basic auth credentials, but for a user that doesn't exist in my LDAP directory, I get a different error response saying that the user was not authenticated. So lastly, if I go to a request that sends a valid user that exists in the LDAP directory using basic auth, I'm back to a successful request. So again, basic auth with LDAP authentication is still commonly encountered in the industry. But OAuth has been around for a long time now. We were one of the first vendors in our space to come to the market with a complete OAuth solution, and it's been hugely successful. Many of our customers use it. We've got some very big customers that is all they use us for. And they like our OAuth toolkit for its flexibility as well as capability. But many of them have unique requirements for OAuth to integrate OAuth with other solutions in their ecosystem. And we make it not only possible to do that, but easy to do that. And to do it at scale for, literally millions, in some few customers' cases, billions of requests per day, right? So let's go back to our policy and have it enforce OAuth. Now, something that we've been working on and what's currently available as experimental and should be advanced to preview soon is the ability to decouple our OTK, but also other industry standard OAuth providers that support token introspection from our gateways while still enforcing OAuth in the API of the gateway. So you'll notice that this gateway that I'm using for demonstration doesn't have our OTK installed on it. Yes, it could be hidden in some of these folders, but it's not. I do not have the OTK on this gateway. Instead, I've deployed the experimental require and introspect OAuth token assertion to this gateway. Which will allow me to require and introspect OAuth tokens as part of the policy of this API on the gateway against our OTK, but we also are designing it in a way that it could work with, any industry standard OAuth provider. So it's configurable in policy, but otherwise driven by some cluster-wide properties to control the different providers it can connect to and the different credentials it connects to those providers with. And then the default provider to use in policy if you don't otherwise override it in policy. So I'm going to go ahead and disable this basic auth. I've added my require and introspect OAuth token assertion. And I'm going to go back to Postman. And now if I just send basic auth, I'm going to get an error message saying that the auth token wasn't found. So now I'm going to go to a message that sends a valid OAuth token for this our Weasley user. And it succeeds. So that's the require and introspect OAuth token assertion in action. It can either require and introspect OAuth tokens without going to an introspect endpoint of an OAuth provider if those tokens are presented as signed JWT tokens. Otherwise, you can configure it for opaque tokens, which could be still a JWT token or otherwise opaque as just a unique identifier of a token that only the provider has access to, in which case it would go back to the OAuth provider to have it introspect that token on its behalf. So very configurable in both ways. So let's add some attribute-based access control, so ABAC, right? And so now this takes it up a level and it's doing authorization based on attributes of the user. And for this, just to save some time, I'm going to go back to my policy and I'm going to include a policy fragment that has that logic for me here. It's this require clearance policy fragment that includes these assertions. So the first thing it does is it gets the JWT token from the authorization header. Then it decodes that token and it sets the decoded payload of the token to this message type context variable. Here I have a disabled set message type context variable assertion just to demonstrate what the contents of that payload would look like at runtime. And what this ABAC policy wants to do is only allow access, only authorize access to an authenticated user if the value of their clearance attribute or claim, if you will, is greater than 1 in this case, right? So it's going to use a regular expression to get the value from the payload, and then it's going to compare that to detect if it's greater than 1. So now if I go back to my Postman collection and send this same request that was previously allowed, it's going, it should have failed. Let me go back here. I have to save and activate my change. It's going to fail, because the clearance of Ron Weasley is not greater than 1. However, H. Potter has greater clearance. So I send a request with a token for him through, and it succeeds. So that's an example of doing ABAC using claims and a JWT token retrieved via OAuth and required and introspected at runtime in the gateway. Next up, let's talk about enforcing a strict interface and validating and optionally encoding input and optionally output, right? 2 other recommendations we made on that last slide of the presentation. And again, in the interest of time, I'm going to include another policy fragment for that, for request validation, which is going to set a context variable to the Open API specification of the Pet Store API, so that I can use my validated against Open API document assertion to validate many aspects of that contract, if you will. including path, method, headers, query parameters, the body, security credentials required, all things that can be specified in an open API specification. We recently enhanced this, so some of these things are new capabilities. And there's additional capabilities that don't manifest themselves at this level, like support for polymorphism when doing schema validation of the body, that were included in those recent enhancements. We actually are in the process of making additional enhancements to this to add support for Swagger 2.0 to this one assertion, and to allow this assertion to load the specification directly in the policy during design time, or to monitor a URL to get updates, get cache, but then also monitor for updates over time of that assertion from an external source, much like we've done for a long time with schema validation, for example. So bottom line is, this is going to become one assertion that's going to do more things with greater flexibility for both Swagger and OpenAPI. 3.0 today, but 3.1 soon going forward. And so that means that as we release these enhancements to this assertion, we're going to deprecate but not remove the Swagger 2.0 validation assertion, encouraging people to move to this over time as a more capable solution that really brings it all back together in a single assertion. Then we're doing some document structure, threat protection, and you'll notice I'm just only allowing a JSON structure depth of 1 just to make it easy to demonstrate. Some SQL injection protection, some code injection protection. These are some common types of protection customers want for their APIs. Now, having made and saved those changes, let me go back to Postman. And first of all, I'll resend a valid request. I should still get back a good response. But now let's go to a request that has that is invalid per the schema. The schema for this pet store API, defines this status as an enum with only 3 allowed values and back orders, not one of those. So I send this request, and sure enough, I get a schema validation failure because we sent a status value that wasn't placed, approved, or delivered. I go to this depth charge API where I'm just showing a not so deep, but deeper than allowed JSON message. And our JSON document structure threat protection assertion is going to identify that and prevent that. And then lastly, I'm going to go to a message in which I have some SQL injection embedded in there. And I'm going to send that request, and we're going to detect that and reject that too. Now, the last thing I'm going to do to my policy based on those recommendations we made is I'm going to add rate limiting to it. And I'm going to use a new preview capability for distributed rate limiting, released in 10.1 CR3, soon to, supporting distributed rate limiting using external Hazelcast, soon to be enhanced in 11 CR2 to also support Redis. So it's called apply distributed rate limit. And this assertion is meant to solve some problems that some customers have sometimes had with our traditional rate limiting, which has always enforced a rate limit in memory per gateway. The traditional rate limiting did have a concept of cluster-wide rate limiting, but all that meant was it would try to detect active gateways in a cluster in some different ways, and then it would divide the rate limit that was configured by the total number of active gateways, and it would still only enforce that derived value in memory per gateway. And so that would create some problems for some customers sometimes. It was a problem if they're trying to enforce really low rate limits across large clusters where the rate limit was actually lower than the number of active gateways. It was a problem if they weren't balancing load equally across their gateways, and some gateways were getting more load than other gateways. They would tend to hit their limits sooner than they otherwise should across the cluster. It's tied very much to either backing your gateways by a database or external Hazelcast. And, so didn't really support distributing a shared rate limit across, database-less ephemeral gateways that didn't use external Hazelcast, or across multiple clusters of gateways, use cases some customers had. So applied distributed rate limiting solves for all those problems. I'm going to go ahead and drag this in here, and I'm just going to go ahead and limit to 2 requests over 1 minute. So the traditional rate limit also only supported per second. We're going to allow per minute rate limits here because some customers have wanted those. I'm just going to set a burst limit of 4. That means I'll be able to get up to 4 requests through before I hit my rate limit. And then after that, if my requests stay constant, I'll only be able to get up to 2 requests per minute. I can see that I have configured this to use external Hazelcast. Again, in 11 CR2, you'll be able to configure this to use Redis. Save that change, and I'll go back to Postman. And now I'll send a valid request several times until I hit that limit. It's as easy as that. And securing your APIs with a policy, based on those recommendations we made, is as easy as this policy. But, some people might not even, find this policy easy to use. It might already be too many policy assertions in the policy for them. And so the last thing I'm going to show you here is just how you can encapsulate some of these fragments for easier reuse. So to that end, I'm just going to go ahead and perhaps we'll take everything below here and we'll create a policy fragment. We'll call this API Runtime Security. Save that change here. I'm going to open up that fragment because you might still want to make it dynamic by using input parameters that users of this eventually encapsulated assertion can provide their own values to. So for example, let's say we want everybody to be able to drag and drop this assertion in their policy, but they might have different rate limits and burst limits for their rate limiting. So I'm going to go ahead and preemptively replace these with context variables to make them dynamic. And then I could just continue to use policy fragments. They're still useful and some people may still prefer them. But for a long time now, we've been able to turn policy fragments into encapsulated assertions that appear as separate assertions in this policy and can enforce a tighter contract and provide a better user experience. So I'm going to do that for this insertion, a fragment, by creating an encapsulated assertion from it. Notice it picked up my 2 context variables that I'm using to drive the rate limit dynamically. I'm going to name this after the fragment itself. For now, I'll put it I'm going to drop it in this custom assertions folder. And I do want this to be configurable as an integer from the UI of this encapsulated assertion. So this is my burst limit. And this is my rate limit. Make this easier to debug here, click OK. Now I can go back to the policy of my API. I can get rid of this fragment if I want. And I can find and drag and drop my encapsulated assertion, which I misspelled. Hopefully you'll forgive me for that. Into my policy, save and activate this. And I get a lot of that, I get all that same behavior, but encapsulated behind a single assertion that's easier for a user to drag and drop in policy. And we're coming up on time. The last thing I was going to talk about, but really at a high level, was monitoring with out-of-the-box auditing and logging, and what that can look like and how you can configure it both on on your gateways and with integrations with, auditing and logging solutions off your gateways. Again, we got a lot of exciting stuff coming up there related to upcoming support for open telemetry. That'll give you new industry standard ways of doing that easier, better with drop-in, deployments in an existing open telemetry environment to get logging, tracing, metrics, in much more useful ways. But why don't I stop now and just take questions in the last few minutes that we have.
Thanks, Ben. If you have questions, please take yourself off mute and go ahead and ask your question.
Hi, Ben. It's Madhav. And first of all, a very fantastic presentation, actually. So I just have a question related to the what require an introspect WAT token. So that one is still in preview, right? It's not in GA, right?
So that does go back to our progressive delivery model, which starts with experimental, then moves to preview before it goes to GA. And right now that assertion is only available as experimental. So if you're interested in it, you can reach out to us, directly via email through our community portal, requesting access to it. And that one would be shared with you as an assertion via box that you could download and deploy your gateways and play with. It is a pretty high priority assertion for us in our cloud deployment initiative, especially to allow decoupling the OTK from your, gateways. And so, we do have it on our short-term roadmap to advance to preview, probably in the next PI to be available as preview in 11.1, possibly. And once a progressive delivery feature has hit preview, that means we're ready to agree to support it in customers' production environments for a limited number of customers. We've kind of combined preview with limited availability in that sense. So if you're excited about it and you played with it and you wanted to use it in prod, that's the timeline for us to have a conversation about us allowing you to do that with our full support.
Got it. And how do we integrate with the external OTK providers in this case, actually? So now that it starts supporting from the gateway perspective, how does gateway rather know that it has to go and look for the OTK related things onto the external ones?
Well, one, it would use that assertion, and that assertion uses cluster properties to tell it which OAuth providers it can optionally rely on to introspect tokens it receives. I'm sorry, it's not that one, it's this one. And so the configuration for that's here.
Oh, okay, got it. Sure. Yeah, and as an extension of it, actually, so it does provide the ability to integrate multiple external OTK providers, right? It's just since
it does, yeah.
Now, okay, got it.
Single instance of the assertion can only introspect against one at a time, but you could have multiple instances in your policies. So yeah, you could support, enforcing OAuth with tokens provided by many different OAuth providers using this one assertion on your gateway.
Yeah, sure. Thanks, Ben. Thank you.
Yeah, you bet. Good questions. It's time, but I can go over a little bit if Bill will let me. Anybody have any other questions that you'd like to ask? Okay, were there any questions in the chat? I never really pay attention to the chat while I'm talking, but yeah.
I'm looking right now. There are a couple. Hang on one second. Let me explode this out a little bit because it's just too small right now. The first question is, will there be a shared presentation? Yes, the presentation will be available up on communities sometime late this afternoon. Let's see. Do you have API management comparative with Apogee? That's an easy answer, but I'll let you take it.
Yes, I mean, we're a direct competitor of Apogee. We've got a full API management solution like theirs. I mean, bottom line, there's almost nothing that Apogee can do that we can't do, and to some degree, vice versa. I guess our position on that would be we're more cloud agnostic. We've got a better on-prem and therefore hybrid solution that more strongly differentiates itself with these security capabilities and with good performance and scale. When Apogee entered the market, it was very focused on providing a SaaS solution for API management, less runtime, API runtime security with a gateway. Their gateway was very lightweight, still is very lightweight, much less capable gateway than ours. Probably is caught up with the most common things customers want to do, though, but certainly doesn't have the flexibility and all the capability that our gateway has for API security.
Yeah, and I think API security is definitely the key. Along those same lines, staying on the competitive side, what is the advantage of Layer7 over WSO2? Similar answer, but take it away.
Well, in many cases, some of the same advantages, right? We've always been a market leader jockeying for position. Really with Apogee, less any of the other solutions, though the market's kind of definitely consolidated, kind of in some ways commoditized. We still strongly differentiate ourselves based on API security against everybody else in the market. WSO2 has always been there as one full API management lifecycle open source solution, but it was never a real viable competitor. It was always very complex to deploy and administrative with fewer capabilities. We never saw it as being very successful against us or any of our closer competitors in the market. So they're not really someone that's top of mind for us even today for all those reasons.
And I'll chime in on that. When I work with partners regularly, I kind of compare our competitors to, even though I don't like the sport, it's a good comparison with baseball. You have your major league, you have your minor league, and then you have your farm teams. And honestly, from our partner perspective and our perspective, and also industry perspective, they're very much a farm team. So we really don't pay as much attention to them as we do with others. One question I would have thought you had answered, but maybe it was just glossed over. Do we have Layer7 as a SaaS service or a cloud provider?
So we do. So Layer7 API management, I guess I could bring up a slide, is made up of multiple products to offer full lifecycle API management of your APIs, and two primary components of that are the gateway, which we focused on in this session, for runtime API security and other runtime capabilities for your APIs. But also we have the portal, which provides user experiences for the publisher of APIs and the consumers of APIs. And yes, we offer the portal as SaaS. We used to offer the gateway as SaaS with the portal, but nobody ever used that effectively. It's not really a practical deployment model for your gateways to use gateways offered by us as SaaS in front of your APIs, always located somewhere else. Everybody wants to locate their gateway as close to their APIs as possible for all sorts of reasons. So we stopped offering it. Most vendors don't offer a SaaS gateway that's being used by many or any of their customers. And I've worked for, in the past, some vendors that have only had a SaaS gateway and then have an on-prem implementation. And believe me, they haven't really got very far with their API management story for that reason. So yes, SaaS portal, no SaaS gateway. But we have a lot of deployment options, as hybrid or in, deploying with SaaS portal, but our gateway deployed on, self-managed, for example, or all of it deployed together as a self-management solution in all the public cloud providers. So Azure, AWS, Google Cloud, for example. So definitely a lot of ways you can deploy us and use us in those public clouds.
A few more questions and we're going to have to kind of close up. One question is, are we going to discuss security around gateway servers or containers in different form factors? And my, from the product marketing side is my stance is we don't care. where you deploy. It's always the same solution with the same level of security.
Yeah, I mean, pretty much everything I showed you today applies to, you know, any of our gateways and any of their form factors sitting in front of any of your services or APIs, right? But we do support multiple different form factors for our gateway, from hardware appliances still, though there's an end in sight for hardware appliances, to VMware virtual appliances, software gateways, container gateways running in Kubernetes. And there might be some different considerations for them. But in general, we offer a lot of form factors so you can deploy us in different ways everywhere. And the core capabilities of the gateway and how you use the gateway tend to stay the same across form factors for your services and APIs.
And then let's do two more. The gateway default error response is in SOAP. Is there a property to change that to JSON by default or based on content type?
There isn't. Well, I mean, so you saw how I did that using the cluster-wide properties by, specifying the template value for the SOAP fault level, and then by creating a JSON formatted template would be a way to globally return a JSON error message by default. That is not operating based upon content type. You've got additional flexibility to control error messaging, including based on content type in policy. And if you want a policy-driven approach that works globally, then you could use our global policy fragments that do pre and post message processing.
And this last one that we'll do isn't so much a question as more of an ask. The Open API validation assertion works fine. However, I wish we could also include an out-of-the-box assertion to generate it for an existing API instead of having to create them from scratch. Thoughts?
Yeah, some I guess we take into consideration. I'd have to give that more thought. The idea of us generating the specification of an API and then enforcing that. Normally we, and in fact, the owners of the Layer7 API gateway in most organizations don't own that API or its contract. And the expectation would be that the owners of the API are creating and maintaining its contract in that form if that's desirable. There may be utilities that already do that, and then you could leverage those to make changes to that specification being enforced by the gateway. But I'd have to understand better the value of us having an assertion that actually creates the specification. Because also, too, the assertion would only do it at runtime. Yeah, this is me thinking out loud. No plans to do it now. It's an interesting request, something I'd have to think about. Something that you could submit as an idea to the community idea portal too, to generate some discussion around it and see if we get some more upvotes to that, to see if that's...
That's exactly how I was going to end that. That's a great place to go to, the communities for ideas. With that, we are definitely well over time, so I'm going to thank everybody for participating with us today, and a special thanks to Ben for doing this session on our security solutions. And stay tuned on communities. I won't know until Monday whether we're going to have a December office hours. There's always an issue of trying to cram it in before Christmas, but if it's not December, certainly it'll be the new year. So we'll stay posted. And again, this will be posted this afternoon at some point. It really depends on WebEx and how fast they get the recording to me. So thank you again, and have a great rest of the week. And for those of you in the US, have a great holiday week next week. And thank you again.
Later, folks.
Thank you. Bye-bye.